Hi, hope you're doing well. I'm going to attempt to go through the MHC and what it does and yeah, make a little diagram. So here we go. Let's try it. Let's try this together. All right. So start out, you're going to have our cell. So this is our cell, and this one is going to get infected. So we'll draw a little red Ebola virus. And we'll bow to convention. We'll put that little curly Q on the top of it. Just like that. There we go. So this is Ebola. Ebola virus, and you write it as if it's all one word. And that's an I right there. Ebola virus. So it goes in the cell, and that's fine. So a cell's job is to let the immune system know that it has been infected. And so the Ebola virus is going to go inside here, and it's going to do the usual. It's going to fuse at low pH. There's going to be histidines that get protonated like they always do. It's, yeah, very, very similar to all the things that we know about already. And so anyway, we're going to start making other Ebola proteins. So let's put them here. And then inside the cell, there's this machine called the proteasome. It looks like a little barrel. And so we'll put a little line here that says proteasome. And the proteasome is going to shred proteins. But it doesn't do it randomly. It only cuts them at certain places. And so we're going to feed these proteins in. So our little proteins here, we'll draw them as if they're nice long proteins. They're going to go in, and little tiny fragments of protein confetti are going to come out the other side, just like so. Now the idea is that this cell is going to try to load some of these onto its MHC. So if we were to zoom in on this area right here, so let's zoom in on that. Here we go. And we're going to have MHC class 1 that's going to be riding along on a membrane. So we'll draw it this way. Let's see. It's got 4 domains. 1, 2, 3, and then 4. This one has the little alpha helix at the top, just like that. And so if we are able to bind this thing, there we go. Actually, that's going to be on the inside of a vesicle, so we better draw that the right way around. There we go. So in a little vesicle in the cell, we're going to transport these little peptides in, and there's a special enzyme that transports them in. You can learn all about it in immunology class. And then we're going to load it up. And so this thing here is the HLA B07, and we actually write that as B star 07. There we go. And so that is a member of this group of proteins that are called MHC class 1 protein, Roman numeral 1, which looks like an I. And so that's going to be HLA type A and type B and type C together are going to be MHC class 1. So just so you know who we're dealing with. So if it is HLA B7, then what it's looking for is the second amino acid here. And if the second amino acid is P for proline, that's how we abbreviate that, then it can bind. And if the second amino acid is anything else, then your HLA B7 is going to say, no, don't want it. Bring me something with proline on the second amino acid, or I don't want it. I don't want to know about it. So if it does make this little connection, then we're going to put this out at the surface, and so you will have the surface of the cell with 1, 2, 3, and then here's our 4th group. And so you'll have a little tiny piece of an Ebola protein glued to the outside of your HLA B7. So there's our HLA type B star 07. And so this is our Ebola peptide. Yeah, sorry, my red marker is a little dim. Yeah, all right. So the next step is that hopefully a wandering dendritic cell comes by. So here's our little dendritic cell. So DC for dendritic. Dendritic cell, just like so. And dendritic cells would also have their own HLA type B molecule on there. And so they're actually going to pick up this peptide. It's going to go away from here, and it's going to go over to there. And then they're going to say, ooh, I got something. And remember, these are our little security guards, our little night watchmen. They don't know what to do with it, but they know when something goes wrong, they got to take it to the boss's office. And so the boss's office is going to be in a lymph node. That's where they're going to head. And so here, let's put a little to lymph node. Okay, and now one moment, let us erase this. Ooh. There you go. It's like Bob Ross in reverse. Look at the happy little viruses disappear. Yeah, there we go. And now we got a nice, friendly, clean, blank slate. Let us continue. Okay, so where we left off, we had our dendritic cell, DC. And young dendritic cell had on its surface that little protein from Ebola virus. And so the dendritic cell can go and show it to a number of different cells so it could interact with. Hence, we'll draw our cells of the immune system in green. We'll have a killer T cell, which is going to be CD8 positive. And so there we go. And it's going to have a thing called a T cell receptor that looks a whole lot like MHC. And it will transfer the peptide again. So it's like a little relay race. Instead of passing the baton, we're going to pass that peptide over. Actually, I think it just makes like a little sandwich on here, but they're both binding to the same peptide. And so let's draw another molecule on here. We'll pretend this one managed to catch two peptides. And so here we go. We'll draw our second little peptide on there, looking great. We can also directly interact with a B cell. And the B cell has on its surface a molecule that looks just like an antibody and will become an antibody if that B cell happens to make a connection. So it's going to try to make a connection, again, trying to make a little sandwich with the MHC class 1, which is, in this case, HLA B star 07, which, remember, this peptide has, so it's going to be 8 to 9 amino acids long, and if it's going to bind B7, it has to have proline as number 2. But remember, there's that chart back in the lecture that shows you what each of these HLA types is looking for, at least all the ones that are thoroughly known. So put a little T in there, boop. And so if we get B cell recognition, then the B cell is going to turn into a cell that produces antibodies. So the B cell will mature to a thing called a plasma cell, and it'll just start making antibodies, which are shaped like little Ys, about like that. And these are going to go out and stick all over viruses, and they'll act as a little handle. They let other cells from the immune system, like macrophages, just pick these up by the hundreds. The T cell, if it is activated, it'll become an activated T cell. Active T. And active T goes out, looking for a cell with that same peptide on it, and it goes out to kill those cells. So, kill infected cells. Yeah, there we go. Great. And if these things happen, this is success. And you will probably live. That is what a good immune response looks like. But if these things don't happen, then here we go. Let's redraw this. Okay. So here is our infected cell. So if the infected cell actually releases whole Ebola virus, so if we get there a little bit too late, then the whole Ebola virus can stick to the outside of the dendritic cell. And so you'll get a dendritic cell, and it's going to have a protein called DC sign, SIGN, all over. And Ebola will stick to that, but it will not use that as an entry receptor. It's just like a little attachment receptor to hitch a ride. So there we go. Try a little, and something like that. All right. And so then DC, the dendritic cell will still try to go to the lymph node, because that's what it's trying to do. When it notices infection, it tries to respond in that way. And instead of presenting, it doesn't have any peptides to present. It's actually got full-on Ebola viruses. And so it's going to run into a macrophage. And the Ebola virus was just waiting for this. It's going to jump off and jump onto the macrophage, because it's going to have that TIM1 protein, so it can enter. And then, boom, we're going to have Ebola loose in the cytoplasm of the macrophage. And the macrophage will do two things. One, it's going to be full of these little granules that contain all our cytokines. It's going to dump all cytokines. And it's going to start producing more virus. Yeah. So it's going to call in more, and then we'll abbreviate macrophages as an M and then the Greek letter phi. That's just how that stands for macrophage in immunologists speak. Macrophage is going to dump all of its cytokines, calling in more macrophages, and then the macrophage, meanwhile, is infected, and so it's going to release more virus. So let's draw some more virus coming out. They'll then infect those macrophages, and so boom, we get this cycle. Macrophage arrives, macrophage gets infected, macrophage dumps all its cytokines, more macrophages arrive, more get infected, more dump their cytokines, and so on. And you have this uncontrolled immune response, and this is the cytokine storm. And the cytokine storm leads to the Punisher skull. There we go. There, we'll make it into a pirate skull. It leads to bad things. Death mostly. So how do you prevent this? You prevent it by being born lucky. If you're born with the right HLA to display Ebola peptides, the right one to display Ebola peptides, if you're born with it, you will display them, and your dendritic cell will work as normal. It won't go off and talk to macrophages. But if it can't, if you're not born with the right HLA type B, then this is what happens. This is the only thing that can happen. So it's more likely the dendritic cell picks up a little peptide and goes and does its job, but only if you have the right HLA that is able to pick up those Ebola virus peptides. If you do that, then it'll be survival. Survival and T cell response. If not, then you will have no survival, no T cell response, yes, cytokine storm, and you will lose all your major internal organs and die of multiple organ failure in most cases. There's not a lot that modern medicine or science can do for you. So there we go. I hope that helped. Yeah. That's been Ebola virus, and I hope you liked it.